Hello students. Today we will study Milne-Thomson's method, that is the method to find analytic function f of z in terms of z whose real or imaginary part is given. Now let us consider one example. If v is 3x square y minus y cube, find its harmonic conjugate u and find f of z in terms of z. Now the given value of v is 3x square y minus y cube. Now dabba v by dabba x will be 6xy and dabba v by dabba x is 3x square minus 3y square. Now from first CR equation we know that dabba u by dabba x is dabba v by dabba y. But here dabba v by dabba y is 3x square minus 3y square. Now integrating dabba u by dabba x with respect to x, treating y as a constant, we get u is equal to 3x cube by 3 minus 3y square x plus say f of y. Now let it be equation number 1. Now from this dabba u upon dabba y will be minus 6xy plus f dash y. Now we know that second CR equation is dabba u by dabba y is minus dabba v by dabba x. So if we put actual values here, we get minus 6xy plus f dash y is equal to minus 6xy. That is minus dabba v by dabba x. Now from this we can say f dash y is equal to 0 or f of y is some constant c. Now equation 1 gives, so we can say from 1 we get u is equal to x cube minus 3y square x plus constant of integration, that is f of y is c. Here if we substitute we get u is x cube minus 3y square x plus c. Now to find f of z, the important part is now to find f of z in terms of z, important substitution is we put x is z and y is equal to 0 in equation 2. So we get basically f of z is what? U plus iv. So f of z u plus iv means we can say this is u plus iv. But u is equal to x cube minus 3y square x plus c plus iv. V is 3x square y minus y cube. So this is nothing but if we put x equal to z and y 0, we get f of z, which is u plus iv, is from equations we can say from the given data v is equal to this, and from equation number 2 and f of z is u plus iv, this is nothing but z cube plus c. Now consider second example here. Second example is here real part of function is given, that is u is given, and we have to find v and function f of z in terms of z. One more thing is harmonic conjugate of u will be v and harmonic conjugate of v will be u. Now u is equal to half log x square plus y square. This is the given data. So dabba u by dabba x will be x upon x square plus y square, and dabba u upon dabba y is y upon x square plus y square. Now again by CR equations we have dabba u by dabba x is dabba v by dabba y. Therefore now we can say from the above data dabba v upon dabba y is nothing but x upon x square plus y square. Now integrating with respect to y, treating x as a constant, we get v is integration x upon x square plus y square dy plus fx. Now this integration will be x as it is, x as it is, then this integration will be 1 upon x tan inverse y by x plus f of x. This is tan inverse y by x plus f of x. Now dabba v by dab, this is basically v. Now dabba v by dabba x is tan 1 upon 1 plus y square upon x square into derivative of y by x, which is minus y by x square, plus f dash of x. Now we can say this is dabba v by dabba x. Now if we simplify this, then x square divided by x square plus y square, means if after simplification we can write this as x square in numerator, x square plus y square into minus y by x square plus f dash x. Now cancelling x square, we get this is dabba v by dabba x is minus y upon x square plus y square plus f dash of x. Now from second CR equation we get, from second CR equation, derivative v with x is minus derivative u with y. That means we can say here dabba v by dabba x is minus y upon x square plus y square plus f dash x is minus sign, this is we have dabba u by dabba y is y upon x square plus y square. So here if we put the value, then we will get these two terms are equal. So from this easily one can say that f dash x must be 0, implies f of x must be some constant. Now after this we can say v is equal to tan inverse, by putting f of x is constant, we can say now v becomes tan inverse we can write it here instead of this. We can say v is equal to tan inverse y by x, tan inverse y by x plus f of x. That is tan inverse y by x plus c, constant of integration. Now as I told you in previous example, for getting f of z, we should put x is z and y is 0 in f of z equal to u plus iv. Here basically u and v are in terms of x and y. So if we put corresponding u and v, which we already got, that x is z and y is 0, we get it is 1 by 2 log z square plus c. But this is nothing but 1 by 2 log z plus c, that is log z plus c. So this is how by Milne-Thomson's method you can find out one can find out analytic function f of z in terms of z by putting x is z and y is 0. And before that we should know what is u and what is v. Now next part is, so let us consider one more example. Find the conditions under which u is equal to ax cube plus by square x plus cxy square plus dy cube is harmonic. Now in previous lecture I have told you that harmonic function means the partial derivatives of that with x and y, first and second order will be continuous, and it should satisfy Laplace equation. Now here if we find out these two derivatives, derivative with x partial derivative, derivative of u with y, again partial derivative, then these are the derivatives. Again if we differentiate, then second order derivative with x is 6ax plus 2by, and second is 2cx plus 6dy. Now for u to be harmonic, it should satisfy this condition, that addition of these two must be 0. And it is given that the function is harmonic, and we should find out the conditions. So by using the data that function is harmonic, we can say addition of double derivative with x is 0. From this, if we separate out the terms x into something plus y into something equal to 0, and after solving these two simultaneous equations, we get c is minus 3a, b is minus 3d, which are nothing but the required conditions. Thank you.